Hi, I'm Miss Hearn. Let's get started. And if you find this video helpful, please remember to give it a thumbs up. That helps other students to find the video. All right, so I want to look a little more closely at the function f of x equals x squared plus x that we worked with a few minutes ago. Remember, we found that its derivative by taking the limit of the difference quotient was f prime of x equals 2x plus 1. So what I'd like to focus in on now is the relationship between their graphs. So it says, consider the graph of f of x equals x squared plus x and its derivative f prime of x equals 2x plus 1. Describe the correlation between the y values of f prime and the slopes of the graph f. So on the left there, I have the graph f of x equals x squared plus x. And here is the derivative f prime of x equals 2x plus 1. So I'm going to graph 2x plus 1 now. And by the way, what is the x-intercept of f prime of the derivative? What would this point here be? Negative 1/2. That's right. Okay, so one correlation that we've already seen was we said that the function f at the x value negative 1/2 has what slope? What was f prime of negative 1/2? Slope of the tangent line. Remember, there was a horizontal tangent line here. The slope was 0, right? And when you're describing the slope of a function, you're describing the value of its derivative, which is why it makes sense that over here on the graph of f prime of negative 1/2 is 0, right? The y value of the derivative is exactly the slope of the original function. So let's see if that's true in other places. For example, what kinds of slopes, and I don't mean a numerical value, but what kinds of slopes do we have on the portion of this graph where the function is increasing? What do we know about the slopes over here? That's right. Remember, when a function's going up, that's a positive slope. So if we look at the derivatives anywhere to the right of negative 1/2, we have all positive slopes, right? And what do we have on this graph over here that corresponds to that? What kinds of y values do we have over here? They're positive because they're above the x-axis, yes? So it looks like when we have positive slopes on this graph on the left, we get positive y values for the derivative. That makes sense because the derivative is supposed to be a formula for the slope. And then that was all of these positive y values. Now on the left side, what kinds of slopes do we have? Here's a tangent line. They're all going to look something like this, right? The function is decreasing, so we have all negative slopes. And then look over here to the left of negative 1/2. This graph has all negative y values. You mean, Kajmala, you're asking how I got the point negative 1, negative 1? I just plugged into the function f prime of x. I plugged in negative 1. You're welcome. Okay, so whenever you look at a function and its derivative, there's going to be this correlation between the graphs. So we're going to practice with that. What I'm going to do is I'm going to give you two graphs, and I want you to figure out which one could be the function and which one could be the derivative. So you're going to have to look at each graph and say, okay, do the y values of this graph correspond to the slopes of the other graph? If so, the one whose y values correspond is the derivative. It's everywhere. Let's look at the next one. So which one do you think is the function f of x and which one is the derivative? A, graph 3 is f of x and graph 4 is the derivative. B, graph 4 is f of x and graph 3 is the derivative. C, both A and B are possible, or D, neither A nor B are possible from the information given. I think on this one, it's really helpful to think about where they have slopes of 0. Remember, when the graph turns around, you get a slope of 0 there. So focus in on that. Okay, so the most popular option was B, and that was correct. Good job. But there's definitely some confusion on it. So let's take a look. So let's start by just assuming that the function that we're taking the derivative of is number 3. Let's just say, okay, what if this was f of x? So if this is f of x, I want to think about its slopes. So where does it have a 0 slope? Where is the slope equal to 0 for what x value? It looks like at the vertex. Yes, there you go. The vertex appears to be on the y-axis, doesn't it? So that means that at x equals 0, the slope is 0. In other words, the derivative at 0 looks like it's 0. We would have a horizontal tangent line there. Does that make sense? Okay, so on the other graph, what would we expect to see? If this was f prime of x, then f prime of 0 should be 0, but it isn't, right? F prime of 0 is not 0. It's something else. It's some negative y value. I don't know what it is, but it's not 0. So it's not possible that this is the graph of the derivative of number 3. Okay, now let's consider the other possibility. What if 4 was the original function and 3 was its derivative? Let's see if that would work out better. Okay, so I'm going to think of this as being f and the other one as being f prime. Let's pretend this is 1 and -1 here, just so that we can refer to it. So we have a slope of 0 wherever the function turns around. So this would be a slope of 0 and this would be a slope of 0. So what that would mean is that we would want the derivative at 1 to be 0 and the derivative at -1 to be 0. And although the 1 and the -1, I'll mark it off over here. Those could be 1 and -1, let's pretend. So it looks like, yeah, this fits the pattern of having a y value equal to 0 where the other function has its slope equal to 0. How about the positives and negatives? So the slope of the purple graph is positive before -1 and after 1. And notice that the y values are positive on the other graph before the points where y is equal to 0 and after, on the outsides, let's say. And then notice that that purple graph is actually decreasing, has a negative slope in between. And here on the other graph, we have y values that are negative in between. So that corresponds as well. So it makes sense to say that graph number 4 is the original function and graph number 3 is its derivative. You see where that's coming from? All right. If you found this video helpful, please give it a thumbs up. That will help other students to find the video.